morning.
My name is Kai Vecchio. With me is Andrew Sawyer and Robert Esperone. Our project is the car quick shift system for the International Formula SAE competition vehicle here at FIU. Our system in this presentation will go over our problem statement, our motivation and objectives we wish to achieve, our design intent, and the initial cost analysis at the end. So our problem statement, what we aim to solve is to figure out how to fix the traditional shift system problem in that there's slow and inefficient shifts between gears. We wish to put paddles behind the wheel of the car in order to alleviate this. So this allows also the driver to keep both hands on the wheel.
All right, so as Kai mentioned, our motivation is to increase driver concentration and safety. We have a better control of the vehicle and faster shift times, reaction times as well to any event that may occur on the track. This will be a first for FIU FSAE, and we hope to set the standard. So this is just a little bit about how the competition is ruled. You can see that we have about the majority of the points is going to be in dynamic events, and although our system is just a small part of the entire vehicle, is directly involved with pretty much everything in the dynamic events. So we want to make sure that our system works effectively.
Okay, so our main objectives for this project is we need to match or improve the time it takes for you to change gears in a car. We also need to match or reduce the weight given for this gear shift system because in the international FSAE competition, reduced weight in the car would actually make it improve in the speed and acceleration. We need the shift time to be under a second because that is currently what it takes for someone to actually shift gears. And we need to keep in mind the cost. We're trying to keep it under 1,000 to maximize our expenses. And we need quick and clean shifts as well. So we need to keep in mind the competition rules. Competition rules state that the driver must exit the vehicle within 5 seconds. In order to do this, the steering wheel must be detachable. So we need to keep in mind all these considerations when we design our product. So our first design for the paddles, it shows the distance we're working with between the wheel and the dashboard as it would. We have about 2.15 inches to keep in mind. So keeping in mind the consideration of the wheel being detachable, we decided to put our prototyping designs as close to the dashboard as we can so that when the steering wheel detaches, the paddles will always be in line with the dashboard, so we don't have to come up with a system, an auxiliary cable or such for the paddles to be detachable. This first design uses a corded system, either wiring or a conductive cord. This next design uses a snap action lever. It's going to basically be able to flex and hit the switch, which is this portion right here. That is the snap action switch, so the levers would actually accentuate the paddles shifting the gears. And with this, we also had to redesign the whole entire bracket system and where it would mount. Our next design is this design right here. It uses a push button system, and it actually flex just like this, and the button would be right here. When we printed this, we need to keep in mind the design of the sizing of the wheels. So by printing this, we see how much we can work with. We can actually make this a little bigger to fit a person's hand better. The struggle with this is where to mount this portion. It'll be just like the previous slide, the previous design. We need a lever to actually hold this where the wheel is. And keeping in mind the 2.15 inches, we need to find a way to actually mount this to be able to have a comfortable position. And also, we need to renovate the brackets as well from the previous design.
All right, so to get the gears shifted, we know that we need about 20-pound force in both the push and the pull direction. We decided to use a double acting cylinder. We chose to go with Bimba an ISO certified company, and they also provide a lot of data for their products, and they have downloadable CAD models. Here's a table where I just simply related the cylinder size to the working pressure to get the pull or push force that it will give you. The 3/4 cylinder allows more flexibility for design error, pressure loss, or any potential for change. The cost difference is minimal. It's not yet determined if that's the one I'm going to go with though. Cylinder will be mounted to reduce the risk of piston rod buckling. So we're going to use a rod clavis end or trunnion in the center. We have yet to determine the clutch actuation. We don't know if it's going to be linked to the pneumatic assembly or a separate electric actuator. And then flow through the pneumatic system will be through polyurethane clear tubing. It'll be rated for the appropriate durameter rating, which will ensure that we have the appropriate working pressure or the temperature. And we have yet to determine the flow regulator or the fluid reservoir, which will most likely be paintball tanks from 9 and 12 ounces, which is a nice size and low weight. And the solenoids will be used to control the flow of the compressed fluid. They'll be run off the 12-volt system, and they will have they'll be normally closed. So once they get the signal, they'll open up and send the compressor to the actuator.
So our tentative design for the closed circuit, we know that we'll be able to be provided 12 volts from the vehicle. So knowing this, we can choose a microcontroller to send the signal to the solenoid in order to activate it. And for our solenoid, we haven't decided which one, our microcontroller, which one we'll be using yet. We'll either be going with an Arduino PIC or TI, depending on which brand we find appropriate. And also we want to note that we do need a transition between the microcontroller and these solenoids in order to not burn out the solenoids to downstep the signal. This is our tentative cost analysis. Right now we're at $162 total. We expect this to rise a bit, but this is a great start as our goal is to stay under $1,000. So in conclusion, this is our project for our car paddle shift system for the International FSAE competition. So our problem statement, we went over our motivation, objectives, and our design intent, and we went over our initial cost analysis as well. This is our Gantt chart for our timeline that we plan on developing in the next few months. Just take a moment. Any questions?
Could you discuss for me or show me where you've addressed the global components?
Right, so the global learning, this is an international competition, so we'll be working with students from the international community. We'll be competing against them and interacting
Do you
with them.
have a slide for that?
No, not just addressing that side, but
Okay, you know, as evaluators, we have a problem evaluating those components. We have line items here, so that's something we need to address.
absolutely.
You were mentioning where to mount the paddles and all that. How do you usually do it in kart or Formula One? How does that go?
They usually do it right behind the steering wheel, and they have like an auxiliary cable connected to the electric circuits to be able to do that, so that when they take out the steering wheel, that it's a regular auxiliary cable, just like you're hooking up your headphones into an iPhone or something, that can be able to snap off. We don't want to do it that way. We would like to have it just mounted there so that it just rotates with the steering wheel, and that way the steering wheel itself, we don't have to change any design, we don't have to add anything, the steering wheel stays the same.
But don't you think having those paddles in the way might get tangled with your suit or something egressing the vehicle?
No, because it's going to stay the same, it's going to be the same as having it on the wheel. So
No, because what you're saying is the Formula One and kart, when they take the wheel off, the paddles go with it, right?
correct,
So all you're left with is a shaft.
correct.
Now, when you get rid of your steering wheel, you're gonna have two paddles in there as well, right?
Yes, but we're making it small enough so that it won't affect the driver area.
Okay.
Because we're gonna have it kind of like a U shape, and then the paddles are gonna be here. So they're gonna be high enough where it's not gonna affect anything, you can remove the steering wheel and get
I'm
out.
guessing they'll allow that, right? That's,
Yes.
okay, yeah, that's fine.
I noticed I didn't realize it at first, there's multiple teams working on FSAE projects. I'm assuming again, this is going into the 2016 competition vehicle?
Yes.
Okay.
So we're gonna,
No, no, that's just, have the teams gotten together and looked at any issues that might come up with integrating all the designs? I know you're looking at it from a component level or individual systems, but you gotta remember, ultimately it's going into the entire vehicle, and we may have to consider any design inputs from other teams as well.
well, see, I'm part of the SAE team, chapter here at FIU, and for the 2016 vehicle, we're basically gonna model off the 2015 vehicle, so there's really not much that's gonna be changing for that competition year. So as you saw, I believe you already saw the aerodynamic package, which will change, and the differential. And aside from that, and our project, I think that's pretty much the only things that are gonna be changing.
Like I said, just make sure you're aware and maybe make a statement saying that there isn't any impact from that.
Following up on what you're saying, which makes sense, so you guys have a project manager, one person in charge of the whole thing?
Yes, sir. It's Dr. Andres Termante, he's the
Okay.
leader of FSAE.
For this component, what standards did you adhere to
For which part is that?
for your component?
So we obviously addressed the rule of the FSAE, but we
No,
also.
you say obviously, I mean, I didn't see anything there that was that
Well, in
obvious.
our report, we addressed that. But also, we also looked at the industry standards of like Formula One. and-
Do you have a slide on there?
Well, I have
We had a few slides that have the rules indicated.
So I have a brief mention on the ASTM standards for the rubber material for any pneumatic lines that we'll be running. We have in the beginning, these are straight from the rule book. So, yeah, most of us placed it.
Oh, that is my question. So you need to have a slide there that addresses that, okay? Specifically for standards.
Absolutely.
May I see your second slide, please? One more. One more. You guys lost me out of the block, unfortunately. So, what I would have liked to have seen that would help me, remember, sometimes your audience, you're gonna have people like me and have no idea what you're talking about, but you need to convince me that I want to buy into what you're doing. So what I would like to have seen is an overall schematic, because you talk about paddles and you're talking about controllers and all these things. I could not understand how all these things went together, because I'm thinking about my foot, I'm thinking about my hands, I'm thinking about detaching and off, and where is 1 second gonna come out, am I shifting? And I was having a hard time putting it together. So I would like to see kind of like some of the other teams have done, a flow chart or an overall schematic where you connect it all together, so I have something that I can grasp, okay? We asked about the shifts and they're not detaching. Are you going to, you're trying out the various paddle options. You have yet to decide which one you're going with?
That's correct.
Thank you.
Okay.
Thank you very much.
Thank you.